Alright guys, hey, this is Mr. Rover. Today we're going to be learning about fossils. As we go through this, I'm probably going to be going pretty fast. Feel free to pause it at any time so that you can fill in the blanks on your notes. They should be underlined in here. But yes, let's go ahead and start into it. Alright, so fossils. That's not fossils. There we go. Okay. So first off, what is a fossil? A fossil is the preserved remains or traces of organisms that lived in the past, usually more than 10,000 years ago. So you're probably familiar with fossils as the things that you see in museums and stuff like that. And of course, dinosaur fossils are one type, but there's many other different types of fossils. In fact, dinosaur fossils are actually one of the rarer types of fossils. So the people that study these are paleontologists. A paleontologist is a scientist that studies fossils. And here's one that worked with Steven Spielberg to help film Jurassic Park. And you can see that dinosaur, the T-Rex in the background there. So how fossils are formed. So in order to form a fossil, two things need to happen. First off, it needs to die. And then it needs to be preserved somehow. And there's many different ways that they can be preserved. And it's going to result in different types of fossils. Alright, so what type of thing do they show us? First off, they can show us the diversity of life throughout the history of the Earth, so basically they can show us the different creatures that exist. Now, something to keep in mind is that most creatures that existed are now extinct. So if you look around and think about all the animals that exist right now, lions and tigers and zebras and all of that, most of the creatures that have existed throughout the Earth's history have died at one point and no longer exist. The dinosaurs are just one famous example of that. We don't even find fossils of all the different creatures. It can also give us clue to climate and environmental changes on the Earth. So the locations of the oceans and the continents have changed over time, and we learned about this back when we talked about Wagner and his theory of continental drift. We can also look at like the scratches that were left by glaciers and the types of ferns that indicate a tropical environment in Antarctica. And they show us changes that have occurred in species and organisms over time. So for example, the giraffe. If we look back in time 100,000 years ago and look at the fossils of the creatures that existed, we don't find any giraffes like they exist today. We find their ancestors that had much shorter necks than they do now, but a lot of the creatures that exist did not look the same 10,000 or 100,000 years ago. So here's some examples of some different fossils. Okay, the fossils gives us clue as to when, where, and how organisms lived. Okay, and the hard parts obviously make the best fossils. Soft things typically are not preserved very well. So in which rock type are most fossils found? They are almost always found in sedimentary rock. Okay, so it says think about what you know about the rock cycle and describe why you think this happens. So take a minute right now, okay, if you need to pause the video, and think, why would I only find fossils in sedimentary rock and not in metamorphic or igneous? Think you know? So metamorphic rocks happen because of heat and pressure, and igneous rocks come from melted rock. So you're not going to find any fossils inside magma or lava. The igneous rock would completely have melted them by that point. And metamorphic rocks are squished and heated together. So once again, if you take fossils and you basically squish it out flat, you're going to lose all the information that would have been there. Alright, so there are 6 types of fossils, but we typically divide them into 3 categories. So these include things like altered remains, organic remains, or original remains, and then trace remains. So let's break it down a little bit more. So these are the 6 types of fossils that you're going to need to know, and this is what your tests are going to focus on. We have molds, casts, petrified, carbonized, true or original remains, and then trace fossils. Alright, so let's start with mold fossils. So mold fossils are one type of altered remain. These are formed when sediments bury and an organism changes into rock. As groundwater enters into the rock, the organism decays and a cavity is left behind in the shape of the organism. So you have something, it gets trapped in rock. As it decomposes, it leaves behind a hollow space where it used to be. Okay? So here are some examples of some mold fossils. You can see it's basically just an imprint of where that creature used to be. And then as they dissolve, they leave that empty space behind. So when you try and remember a mold and a cast, think of like a jello mold. A mold is hollow. It allows you to fill stuff in. Now, once they're filled in, the filled in pieces are called casts. So when a mold is filled with mineral-rich sand or mud, eventually the sand or mud will harden inside that hollow spot, and then the hardened sand or mud has the shape of the original organism. So looking at some pictures of that, we can see this trilobite here, and we can see this imprint of the shell off to the side. So basically these were hollow areas that got filled in, it hardened, and then you could take them out. So once again, thinking about a Jell-O mold, if you filled a Jell-O mold with Jell-O and the Jell-O hardens, when you take it out, it's now in the same exact shape and form of that mold. Okay, and so you're looking for cast fossils and then copy on your sheet there. Okay, so here's two examples of some cast fossils. So the one on the right, you can see it's got a plastic mold and it's been filled in with what looks to be plaster of Paris, maybe some plastic. And then on the left side there, we've seen these pictures before. So these are the people that were trapped at Mount Vesuvius at Pompeii. So when they died, they got buried with ash. And then over time, their bodies decomposed and they left these hollow spaces inside the hardened rock. And then people came in, we filled them with plaster of Paris, and so now we've got the shapes that remain. Okay, altered remains. Here's some a leaf. Okay, so mold and cast summary. A shell or a bone is buried in mud, which hardens. The object dissolves, and it leaves behind a mold, which is the hollow space, and then it's filled in, and this creates a cast. So the difference between a mold and a cast, I'm going to tell you right now, is one question that a lot of people typically get wrong on their tests. So make sure you keep that in mind. Now, they are the most common type of fossil. We find those the most often. Another type of fossil are trace fossils. So these are things that were not a part of the original organism. These things were not alive. So things like footprints, trails, nests. Trace fossils do not contain any parts of the organism. These fossils are formed when mud or sand hardens to stone and when a footprint, trail, or burrow of an organism is left behind. So we can see footprints here and then the trails made by worms. Okay, trace part. No part of the organism left, only traces of where it was. Okay, traces that it was there. Okay, so keep that in mind. Trace fossils are just traces of the organism, not a piece of it. All right, so here's some examples. We can see some footprints. Okay, trails, footprints, tracks in the mud can give evidence of an organism. They can tell us about its size, depending on how big the tracks are, its mass or how heavy it is, how much it sank into the mud, as well as how far they or how fast they were, how they moved. So by looking at how long a creature's legs are and by seeing how far apart the legs are spaced, we can tell how fast it traveled. And then there's another example there. So here's some more trace fossils. We've got a footprint, some dinoduci, some coprolites, and then some swimming tracks. Okay, so these are not parts of the original organism. They were not a piece of the creature. Okay. The next type of fossil, these are preserved or true remains, so the original remains of an organism. So these fossils form when entire organisms or part of the organisms are protected from scavengers, oxygen, and bacteria by being trapped in rock, ice, tar, or amber. Okay, so here we can see the skull of a direwolf. So a direwolf is like the wolves that we had today, but they were much, much larger. And so this creature got stuck in a tar pit in California, and it basically got buried in the tar, and the tar act to preserve it and keep these things from decomposing. It can be found in ice, frozen, tar pits, caves, where they can be naturally mummified. The humidity can come out. As well as amber. If a creature gets stuck inside tree sap, it can harden around the creature, and basically the creature's stuck inside this rock. Here we can see a mummy that was found obviously in some frozen area, and just over time it became dehydrated, but we can still see the organism. Okay, and then there's a spider that's trapped in amber. This is baby mammoth. This is one of the best preserved specimens ever found. It was found trapped in the ice in Siberia. Insects like the spider were often preserved in hardened tree sap. That's called amber. Okay, and we can see almost all of the features of the creature here. Petrified or permineralized fossils. These are another type of altered remains. These fossils form when mineral water solutions soak into the buried remains of the organisms. The minerals dissolved in water replace the organic remains cell by cell, changing the remains into rock. So basically what happens is you have a bone. It gets buried, And over time, water seeps in and starts to dissolve the bone. But instead of dissolving away, the calcium that's in the bone gets replaced with other minerals, such as silicon. And as these atoms are replaced one at a time over thousands or millions of years, eventually you get to the point where the entire bone, all the calcium has been replaced with silicon, and it's not a bone anymore. It's turned into a rock that's in the exact same shape of the original. All right, so we're going to fill this in on your graphic organizer. Petrified. Okay, petrified is when organic matter is replaced by minerals in water, and it makes a rock-hard copy. Okay, so once again, if you need to pause it, go ahead and do that. Okay, some petrified fossils. So common examples, dinosaur skeletons, okay, the ones that you'd see in museums. These are typically examples of petrified fossils where the minerals have been replaced over a period of time. Now just know that the ones that you actually see in the museum, they're typically replicas, they're typically not the originals. So yeah, just know when you look at a dinosaur in a museum, it's typically made of plaster of Paris, but it's been made as a copy of the original bones that they would have found out in the deserts. Some other examples, petrified wood. So Arizona has an entire forest of logs that have been petrified by this process. And so these are no longer made of wood, they're made of rock. These are rocks that are the exact same shape and size as the original wood that it came from, but they've been completely turned into rock. And then the last one, carbonized fossils. Okay, so everything that's alive is made of the element carbon, which is black. Carbonized fossils form when organisms or part of an organism are pressed between layers of soft mud or clay that hardens. Now, over time, this process squeezes the decaying material away and leaves just an imprint from the carbon in the organism in the rock. So basically what you're seeing is the carbon that's left behind from where these creatures used to be. So here you can see the imprint of this fern that has the carbon left behind, and here's the imprint of a fish. Okay, here's some more pictures. Okay, carbonization. Carbon in dead organisms is pressed out of the sedimentary rock, and then the carbon outline remains. Okay, and it's typically the most type of way that we plant fossils. They typically don't make casts or molds. They typically don't become petrified, but we can find the carbon of where they used to be. And here's an example of a carbonized fish. Alright, so this is the end of the notes for today. There's going to be another assignment in Schoology that you guys are going to go ahead and work on. Once again, if you need to go back and re-listen to any of this, feel free to do that. If you have any questions, I will be on the Zoom room. Go ahead and log into that if you want, or if you have something else, you can feel free to email me as well. Other than that, I hope you guys have a good day, and I will see you tomorrow.